Okay, welcome. Sorry, I had to test my mic, see if it was working. This is 8.5, sum and difference formulas. So I think we're gonna learn 6 formulas today. Sum and difference formulas for cosine, sine, and tangent. So here's where we start with. We start with the sum and difference formulas for cosine. So the first one is cosine alpha plus beta can be expanded into cosine alpha times cosine beta minus sine alpha times sine beta. And the second one is the difference formula. Cosine alpha minus beta can be expanded into cosine alpha times cosine beta plus sine alpha sine beta. And the reason we create these formulas or use these formulas is to help us find the exact value of an angle that you cannot find on the unit circle. So we are able to take that angle, split it into 2 angles that belong on the unit circle, and then we can apply the formula to it. So yes, have your unit circle out for this. Okay, and what I mean by a value of an angle you can't find on the unit circle is just something you don't see on there. Like our first example is cosine of 75 degrees. Look at your unit circle. Do you see 75 degrees on there anywhere? It's in there, but do you see it? No, right? We only have values for 30 degrees, 45 degrees, 60 degrees, 90 degrees, no 75 degrees. So this is why the sum and difference formulas were created. So this means we're going to take 75 degrees, split it into 2 angles, alpha and beta. And those 2 angles must belong on the unit circle. So when I split 75 degrees up, it would be wise to split it up as the cosine of 45 degrees plus 30 degrees. Because 45 plus 30 is 75 degrees. Now, my question to you is 45 degrees and is 30 degrees on the unit circle? And that answer is yes, which means we can now go ahead and use our sum formula for cosine. So we're going to use the sum formula for cosine. Cosine alpha, cosine beta, minus sine alpha, sine beta. Okay. So when I expand this, I get cosine of 45 degrees times the cosine of 30 degrees minus the sine of 45 degrees times the sine of 30 degrees. Just like the formula above. Cosine 45, cosine 30, sine 45, sine 30. Okay. And also, if your question is, well, which one was alpha and which one was beta? Well, it's kind of how you line them up, right? 45 was my alpha, 30 was my beta. And if you switch them around, you would still get the same value. Okay, say you put it as 30 plus 45, then we would get the same exact value. Okay, so now let's simplify using the unit circle. So cosine at 45 degrees. What is cosine at 45 degrees? Cosine at 45 degrees is square root 2 over 2. Now, what is the cosine at 30 degrees? Cosine at 30 degrees is square root 3 over 2. Minus, what is sine at 45 degrees? Sine is square root 2 over 2. And then what is the sine at 30 degrees? Sine at 30 degrees is 1/2. Now, multiply your fractions. Square root of 2 over 2 times square root of 3 over 2 is the square root of 6 over 4 minus the square root of 2 over 4. And I think my math lab wants you to put them together. So your final answer can be square root 6 minus square root 2 all over 4. There it is. And that is the exact value of 75 degrees. Square root 6 minus square root 2 over 4. That's how we use the sum of difference formulas, and that's how we apply the unit circle to them. Okay, perfect. Okay, so cosine of pi over 12. Again, we need to find a way to split pi over 12 into two angles that belong on the unit circle. So cosine of pi over 12, I'm thinking we can split this into the cosine of 4 pi over 12 minus 3 pi over 12. Because 4 pi over 12 minus 3 pi over 12 is pi over 12. Now, all we have to do is reduce the angles on the inside. So 4 pi over 12 becomes, 4 pi over 12 becomes pi over 3 minus 3 pi over 12 becomes pi over 4. Okay, and now on your unit circle, can you find pi over 3 and can you find pi over 4? And yes, those are on your unit circle. So now we use the difference formula for cosine, which is right above, cosine alpha minus beta, cosine alpha, cosine beta, plus sine alpha, sine beta. So we use that. Okay, meaning that this will expand to cosine of pi over 3 times the cosine of pi over 4 plus the sine of pi over 3 times the sine of pi over 4. Okay. Now all we have to do is simplify. And what is cosine at pi over 3? Cosine at pi over 3 is 1/2. Cosine at pi over 4, square root 2 over 2, plus the sine at pi over 3, square root 3 over 2, times the sine at pi over 4, square root 2 over square root 2. Simplify, and you get square root 2 over 4 plus square root 6 over 4. Put it together, square root of 2 plus square root of 6 over 4. And there you go. That is the cosine of pi over 12. Okay, very similar to the one above it. That one above is square root 6 minus square root 2 over 4. This one's square root 2 plus square root 6 over 4. All right, I'm gonna take a small break. Okay. Same thing here, cosine of 7 pi over 12. Look at your unit circle. You don't see 7 pi over 12, which means we have to split it into two angles. So 7 pi over 12, well, I can take an example from the one above. I can do 4 pi over 12 plus 3 pi over 12. Why not? That makes 7 pi over 12. So if I split that up, cosine of 4 pi over 12 plus 3 pi over 12. That makes 7 pi over 12, which means reduce the angles, and you get pi over 3 plus pi over 4. Now use the sum formula for cosine, and you get cosine pi over 3 cosine pi over 4 minus sine pi over 3 sine pi over 4. Okay. Unit circle time. Cosine at pi over 3, 1/2. Cosine at pi over 4, square root 2 over 2. Sine at pi over 3, square root 3 over 2. And sine at pi over 4, square root 2 over 2. Okay. And then multiply square root 2 over 4 minus square root 6 over 4 gives me square root 2 minus square root 6 over 4. There we go. That is the sum and difference for cosine. 2 formulas now. Many more to come. Next is sum and difference for the sine function. All right. So first one up, sine alpha plus beta is expanded into sine alpha cosine beta plus cosine alpha sine beta. Then the difference formula, sine alpha minus beta is sine alpha cosine beta minus cosine alpha sine beta. So now we have 4 formulas. 2 sum and difference for cosine, 2 sum and difference for sine. Okay, so again, we do the same thing. Sine is 7 pi over 12. You don't see it on your unit circle, so split it into 2 angles. And 7 pi over 12 is the same angle we had on the last example. So this means, again, I can say sine of 3 pi over 12 plus 4 pi over 12. That makes 7 pi over 12. This gives me the sine of pi over 4 plus pi over 3. Now use the sum formula above for sine, and we will get the sine of pi over 4 times the cosine of pi over 3 plus the cosine of pi over 4 times the sine of pi over 3. Okay, now unit circle time. Sine of pi over 4, square root 2 over 2. Cosine of pi over 3, 1/2. Plus cosine of pi over 4, square root 2 over 2. Sine of pi over 3, square root 3 over 2. Put it together. Square root 2 over 4 plus square root 6 over 4 gives me square root 2 plus square root 6 over 4. See how all these answers are related in some way. They all look the same. Okay. Perfect. All right. So now the next one, find the exact value of the sine of 80 degrees times the sine of cosine of 20 degrees minus the cosine of 80 times the sine of 20. So here we want to take a sum or difference formula and work it backwards. So this one's in the form of sine cosine minus cosine sine, which means that we can compare it to one of the formulas above. Sine cosine minus cosine sine, which means we can take this and rewrite it back as just sine alpha minus beta. So that's what we're going to do for that problem. So sine 80 of cosine 20 minus cosine 80 of sine 20, all of this becomes sine of 80 degrees minus 20 degrees, which then becomes the sine of 60 degrees. And the sine of 60 degrees, well, look at your unit circle, sine of 60 is square root 3 over 2. There it is. Okay. And now we'll do it again. Cosine 70 times cosine 20 minus sine 70 of sine 20. This one is related to cosine alpha plus beta. It's related to that formula. So all of this will become cosine 70 plus 70 degrees plus 20 degrees, which gives me the cosine of 90 degrees. And the cosine of 90 degrees is, guess what? 0. Okay. Perfect. Do it again one more time. Sine of pi over 12 times cosine 7 pi over 12 minus cosine pi over 12 times the sine of pi over 12. This one is just like the first one. This is related to sine alpha minus beta. Sine alpha minus beta. So all of this becomes the sine of pi over 12 minus 7 pi over 12. Sine of pi over 12 minus 7 pi over 12. Okay, so simplify that, and you get the sine of negative 6 pi over 12, which gives me the sine of negative pi over 2. Okay, and since sine is an odd function, this becomes negative sine of pi over 2. And sine at pi over 2 is 1, but that negative's waiting on the outside, so this becomes negative 1. There we go. So that is the sum and difference formulas for sine and cosine. Okay. Perfect. So we get a whole page for this one. It says, find the exact value of the expression secant of pi over 12. Well, we don't have a sum or difference formula for secant. We only have it for sine or cosine. But we do know that secant is the reciprocal function for cosine theta. So this means that we can rewrite this expression as 1 over the cosine of pi over 12. Now, we can take that pi over 12 and split it into two angles. So this becomes 1 over the cosine of, I'll pick 4 pi over 12 minus 3 pi over 12. Because 4 pi over 12 minus 3 pi over 12 gives me pi over 12. Okay. And honestly, you can choose any radian values that you want as long as it gives you pi over 12. But just make sure those radian values that you choose are actually on the unit circle when you reduce them, right? So this becomes 1 over the cosine of pi over 3 minus pi over 4. And now we can apply the difference formula to cosine. So this becomes 1 over cosine pi over 3 times cosine pi over 4 plus sine of pi over 3 times the sine of pi over 4. Ooh, messy, right? Which means that this becomes 1 over the cosine of pi over 3, which is 1/2. The cosine of pi over 4, which is square root 2 over 2, plus the sine at pi over 3, square root 3 over 2, and the sine at pi over 4, square root 2 over 2. Okay, this becomes 1 over square root 2 over 4 plus square root 6 over 4, which then becomes 1 over square root of 2 plus square root of 6 over 4. Now we can't leave it like that, so we reciprocate it, right? We multiply by the reciprocal. So you get 4 over square root 2 plus square root 6. But now, can we leave it like that? The answer is no. You must multiply by the conjugate of the denominator. So we multiply by square root 2 minus square root 6 over square root 2 minus square root 6. It's the conjugate. There's our conjugate. Okay, which means that I get 4 times the square root of 2 minus the square root of 6 over, and if I FOIL this, see, FOIL these two, I'll get square root of 2 times square root of 2. So square root of 2 times square root of 2 will give me 2. Square root of 2 times negative square root of 6 plus square root of 2 times square root of 6, my middle terms will cancel. And all I'm left with is square root of 6 times negative square root of 6, which gives me negative 6. Now I have 4 times square root 2 minus square root 6 all over negative 4. My 4's cancel, and I get square root of 2 minus square root of 6 over negative 1 move that negative to the top. This negative will change the signs on both terms. So this means I am left with square root 6 minus square root 2. Yeehaw. Oh man, that was fun. Okay, moving on. Another example, if cosine equals 1/4 and theta is in quadrant 4, find the exact value of sine theta minus pi over 6, and cosine theta plus pi over 3. Okay, so the first thing we want to do is use the given information to draw my right triangle. So here's my unit circle. Oh, that's big. Oh well. Okay. And it says we are in quadrant 4, so my theta is down here. Here's theta. And if it says is cosine is 1/4, this means cosine puts adjacent over hypotenuse. So then by Pythagorean theorem, what's that? 16 minus 1, you get 15. This height should be negative square root 15. Because you would have 1 squared plus b squared equals 4 squared. And then b squared would equal 16 minus 1. B squared would equal 15, giving me the square root of negative 15. Okay, and it's negative because it's in the 4th quadrant. Okay, so with that being said, based on our angle of theta, we can find the value of sine. Sine of that theta is going to be opposite over adjacent. So negative square root 15 over 4. Okay, perfect. Now move on to this one. This one's sine of theta minus pi over 6. So we learned formulas to expand the difference inside a sine function. So this means that this becomes sine theta of cosine of pi over 6 minus cosine theta of the sine of pi over 6. So we expand this by the difference formula for sine. Okay, and now when I say sine of theta, I am referencing the unit circle that I drew. So that sine of theta, which we found above, is negative square root 15 over 4. Cosine at pi over 6 is square root 3 over 2. Cosine of theta, which is given by our triangle, or also given by the original information. Cosine theta is 1/4, or use the unit circle. Cosine theta here is still 1/4. So that becomes 1/4 times the sine of pi over 6, which is 1/2. Okay, cleanup time. You get the negative square root of 45 over 8 minus 1 over 8. Now the square root of 45, does that break down? Yes. This becomes square root 9, square root 5. Square root of 9 is 3. So the square root of 45 is the same as 3 square root 5. And this means that that becomes negative 3 square root 5 minus 1 all over 8. That's it. Okay. Do it again. You want to know the cosine of theta plus pi over 3. So now we expand it by the sum formula for cosine. So this becomes cosine theta times the cosine of pi over 3 minus the sine of theta times the sine of pi over 3. Okay, now from the above, cosine theta was 1/4. Cosine of pi over 3 is 1/2 minus the sine of theta from the above triangle is negative square root 15 over 4. And the sine of pi over 3 is square root 3 over 2. All right, once again, cleanup. You get 1/8 plus square root 45 over 8. Put it together. Remember, square root of 45 breaks down. This becomes 1 plus 3 square root 5 over 8. There you go. That's it for that one. Okay. All right. So next, use sum and difference formulas to find exact values. Sine alpha is 4/5, and between pi over 2 and pi, and sine beta is negative 2 over square root of 5, and between pi and 3 pi over 2, find the exact values of cosine alpha, cosine beta, cosine alpha plus beta, and sine alpha plus beta. Okay, so the first thing we want to do for this example is draw the exact location of where angle alpha and where angle beta is, okay? So let's go ahead and do that. We'll make little unit circles for that. So for alpha, here's my unit circle, and it says alpha is stuck between pi over 2, which is up here, pi over 2, and pi. This means that we are stuck in quadrant 2. So here is alpha. Okay, and it's giving us from the above information that sine alpha is 4/5. So sine puts opposite over hypotenuse. So this means that the height of the triangle is 4. The hypotenuse is 5. This means the base must be negative 3. It's a 3, 4, 5 triangle. And the reason the base is negative is because we are in quadrant 2. Okay. So now we need a right triangle for beta. It says beta is stuck between pi and 3 pi over 2. Pi and 3 pi over 2. This means beta is stuck in quadrant 3. So there's beta. Okay. And we're given the ratio for sine beta. Sine puts opposite over hypotenuse. So this means that the height of the triangle will be negative 2. The hypotenuse will be the square root of 5. And then by Pythagorean theorem, what's that? Negative 2 squared plus b squared equals square root of 5 squared. That's 4 plus b squared equals 5. Move the 4 over, b squared equals 1. So this means that the base is going to be negative 1. Okay. We have all the information we need for alpha and beta, which means we can answer the questions above. What's cosine alpha, cosine beta, cosine alpha plus beta, and sine alpha plus beta. So that's where we'll start. We'll say number 1. Cosine of alpha. And I'll put it in red or maroon, whatever this is, just to show you which one we are accessing, which triangle we should use. So cosine of angle alpha uses this triangle. So cosine of alpha would be negative 3/5. So cosine alpha would be negative 3/5. Which brings us to 2. We want cosine beta. And beta, we are referencing the second triangle. So cosine beta puts adjacent negative 1 over hypotenuse square root of 5. Go ahead and rationalize that. That becomes negative square root 5 over 5. Okay. Which means that all that's left is cosine alpha plus beta and sine alpha plus beta, which we will expand by the sum formulas we learned earlier. So first up, cosine alpha plus beta, 3. Cosine alpha plus beta will expand into cosine alpha, cosine beta, minus sine alpha, sine beta. Look how color coordinated that is. My goodness. So you know what triangle we are referencing. Okay, so cosine alpha, we have that value listed right there, right? Cosine alpha is right there, negative 3/5. So that's what we're going to use. And cosine beta is right below it. So that's what we plug in. So cosine alpha, you get -3/5 times cosine beta, -√5/5, minus sine alpha, which is at the very top, sine alpha, which is 4/5. 4/5 times sine beta, which is also given in the very beginning, or use your triangle. Sine beta, -2 over the square root of 5, right? Let's go ahead and rationalize that already. Let's make that -2 square root 5/5. So that's what we're going to put down here. -2 square root 5/5. Now clean up. We get 3 square root 5/25, and then plus 8 square root 5/25, which combines to 11 square root 5/25. Okay, I kind of didn't leave space for the fourth one, but I can fit it somewhere. I'll fit it up here somewhere. 4 wants sine alpha plus beta. So 4 sine alpha plus beta. Expand it, you get sine alpha cosine beta plus cosine alpha sine beta. Now, reference all the information you have. Sine alpha was 4/5. So that was 4/5. Cosine beta is negative square root 5/5 plus cosine alpha, which is -3/5, times sine beta, which was -2 square root 5/5. Right? Sine beta was that -2 square root 5/5. Okay. Perfect. Clean up. -4 square root 5/25 plus 6 square root 5/25 equal to 2 square root 5/25. There you go. That's what we do there. Okay. We would do the same thing below for everything that we did above, but I'm going to move on so I don't take too long. I will fill these out on the notes later, of course. It's the same exact process. Okay. So now we're back to proving identities using sum and difference formulas. So we want to establish the identity that cosine alpha minus beta over sine alpha sine beta is equal to cotangent alpha cotangent beta plus 1. Okay. So for identities, choose the more complicated side or more complicated looking side. And for this one, of course, it's going to be the left side. You could definitely prove this one by the right side, but let's go ahead and do this one by the left side. So we're going to say left side. And we're going to start with cosine alpha minus beta over sine alpha sine beta. Expand the numerator by the difference formula for cosine. Cosine alpha, cosine beta, plus sine alpha, sine beta, all over sine alpha, sine beta. Okay. Now the next thing we want to do is, of course, always think algebraically. How do we get it to look like the right side? Well, we notice that there are two terms in the numerator over the same denominator, which means we can split this into two fractions. So this will become cosine alpha cosine beta over sine alpha sine beta plus sine alpha sine beta over sine alpha sine beta. Well, one thing we notice is that all of this over itself will cancel, right? Sine alpha over sine alpha is gone. Sine beta over sine beta is gone. So this whole thing just becomes 1. So we have the first piece of the right side. Okay, but then what else we notice is that, well, cosine alpha over sine alpha. Remember that cosine theta over sine theta is the same as cotangent theta. So this will become cotangent alpha, and the same can be said right here. That will become cotangent beta plus 1. Now, did we make the left side look like the right side? And that is good. Okay, perfect. Do it again. Sine theta, sine of pi over 2 plus theta equal to cosine. Again, prove this identity, choose a more complicated side, and that side seems like the left side. So we start with sine pi over 2 plus theta, which means that we can expand this by our new sum formula for sine, which is sine of pi over 2 times the cosine of theta plus cosine of pi over 2 times the sine of theta. Okay. Almost there. Reference your unit circle. Sine at pi over 2 is 1 times the cosine of theta plus cosine at pi over 2 is 0 times the sine of theta. Well, 1 times cosine is cosine theta, and 0 times sine is 0. So we get cosine theta. Did we make the left side look like the right side? And that answer is again, yes. Proof. Okay. So much room. Sorry. Okay. So here are the last two formulas for today. This is the sum and difference formulas for tangent. So tangent alpha plus beta is given as tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta. Tangent alpha minus beta is given as tangent alpha minus tangent beta over 1 plus tangent alpha tangent beta. Okay, these are 6 formulas today. 6 sum and difference formulas for cosine, sine, tangent. So let's go ahead and prove that tangent of theta plus pi is equal to tangent theta. Okay, and we can do that by using our new sum formula for tangent. So let's go ahead and do that. This is a proof by the left side. And we start with tangent of theta plus pi, which gives me, by the sum formula above, tangent of theta plus tangent of pi over 1 minus tangent theta times tangent of pi. Now, look at your unit circle. And what is tangent at pi? Remember, at pi, the coordinates are -1, 0. Tangent puts y over x. So tangent puts 0 over -1, which means tangent at pi is just 0. So tangent at pi is 0. So you get tangent theta plus 0 over 1 minus tangent theta times 0, which then becomes tangent theta over 1, which gives us tangent theta. Okay, did we prove the left side looks like the right? And we have. Okay. Let's do it again. Prove the identity tangent theta plus pi over 2 equals negative cotangent theta. Well, I'm going to tell you right now that the sum formula for tangent does not work. If you try to do the sum formula, you're going to get left with tangent theta plus the tangent of pi over 2. Well, what coordinates are at pi over 2? Pi over 2 has the coordinates 0, 1. Tangent puts y over x, which means you would get 1 over 0, which is undefined. So the result would become tangent theta plus undefined, which does not lead us to here. So that does nothing for us. So the sum formula for tangent will not work on this, which means that we have to find an alternate method. Well, think of identities, right? Bring in identities. Remember that tangent theta is the same as sine theta over cosine theta, which means we can change this tangent theta plus pi over 2 into its identity form of sine over cosine. So that's what we're going to do here. So this is a proof by the left side. And we're going to make this in, so I'll start with tangent theta plus pi over 2. And this will become sine of theta plus pi over 2 over cosine of theta plus pi over 2. Now, we expand the numerator and the denominator by the sum formulas we learned today for sine and cosine. So we get sine theta of cosine of pi over 2 plus cosine theta of sine of pi over 2 over cosine theta cosine pi over 2 minus sine theta sine pi over 2. So now we have expanded it. Okay, so now reference your unit circle for cosine of pi over 2, sine of pi over, and sine of pi over 2. So this would give me sine theta times 0 plus cosine theta times 1 over cosine theta times 0 minus sine theta times 1. You get 0 plus cosine theta over 0 minus sine theta, which then becomes cosine theta over negative sine theta. And remember, cotangent theta is the same as cosine theta over sine theta. which means that this becomes negative cotangent theta. Did we make the left side look like the right side? Yes. After much torture. Okay, perfect. Awesome. So those are the sum and difference formulas for tangent. Let's keep going. What do we have left? What do we have left? That, three more. Okay, perfect. Okay. All right, so use sum and difference formulas involving inverse trig functions. Oh, these are fun. Okay, so find the exact value of sine of the inverse cosine of 1/2 and the inverse sine of 3/5. So here we're gonna have to bring back some inverse properties. And when I say properties, I just mean restrictions. So what we wanna do is compare this to the sine of alpha plus beta. Something we learned today, the sum formula for sine. This means that the inside cosine is going to be my alpha. The inverse sine is going to be my beta. So alpha is going to contain its own piece of information and beta is going to contain its own piece of information. This is kind of what we did in 8.2 when we had, let's say I wrote it down, sine of inverse cosine of 1/2. We would let theta equal all this information and create a right triangle for theta. That's what we did in the beginning of 8.2. So this is going to be the same exact thing, except we're doing it with alpha and beta. So we're doing it with two angles. So alpha and beta will have their own pieces of information. So with that being said, let's go ahead and find all the information for alpha. Well, actually, can't do that just yet. Okay, so all the information for alpha. So since we're letting alpha equal the inverse cosine of 1/2, that's what I'm going to write here. All right, trying to see a better way to label this. Information for alpha. Here, I'll just write this. This will be for alpha. Okay, so now alpha equals the inverse cosine of 1/2. Which then means, like we did for theta, you will compose both sides with the cosine function. So this becomes cosine alpha equal to 1/2. Now here's where the inverse restrictions comes in. Cosine alpha can only equal 1/2 on the inverse restrictions of 0 to pi. So now, what we do with that information is now we draw our right triangle. So here's my unit circle for cosine. We exist from 0 to pi. And if cosine is a positive 1/2, this means we must be in quadrant 1. So here's where my alpha lives. Okay, and now to fill out the rest of the triangle, if cosine alpha is 1/2, cosine is adjacent over hypotenuse. So this means that the base will be 1, the hypotenuse will be 2, and by Pythagorean theorem, you should get the height as the square root of 3. Okay, so now this is all the information contained in alpha. Alpha now contains all of this information. Let's now do the same for beta. So once again, we start with beta equals the inverse sine of 3/5. Compose both sides with the sine function. You get sine beta equal to 3/5. But this can only happen on the inverse sines restrictions of -pi/2 to pi/2. So now we draw the unit circle for beta. And down here is -pi/2. And up here is pi/2. Since sine is a positive 3/5, this means that my triangle must be in quadrant 1. So there's beta. Okay. Now fill out the pieces of your triangle. Sine of beta is 3/5. Sine puts opposite over hypotenuse. So the height must be 3. The hypotenuse must be 5. And the base must be 4. 3, 4, 5 triangle, right? Okay, now again, beta now contains all of this information. So we've made a substitution, right? So alpha has all that information, beta has all that information. Now let's bring our substitution back down. So now cosine inverse is alpha, sine inverse is beta. So the way I will rewrite this is as sine of alpha plus beta, which you can expand by your sine formula, your sum formula for sine. So this becomes I should change color. Sine of alpha times cosine beta plus cosine alpha sine beta. Now all we have to do is call on the appropriate triangle to fill in the rest of the information. So looking at the above, sine alpha, based on alpha's triangle, the sine of alpha is square root 3 over 2. Cosine of beta is going to be calling on the green triangle. Cosine of that beta puts 4 over 5. Plus cosine of alpha, which is given by the alpha triangle, and by it's already given up here, right? Cosine alpha is 1/2. So that gives me 1/2. And the sine of beta, which is given right there, is 3/5. Okay, put it together, and we get 4 square root 3 over 10 plus 3 over 10. And my final answer is 4 square root 3 plus 3 over 10. And that's how we work those. All right. Not bad. So make your substitutions, alpha and beta. Remember your inverse restrictions. Make the appropriate unit circle for both alpha and beta, and then apply the appropriate sum or difference formula for the trig function, and just call on the appropriate unit circle, alpha or beta, to get your information. Plug them in, multiply, simplify, that's it. Okay. B is exactly the same as what we did above, so I won't cover that, but I will do it for the notes. I just want to jump to the very last one because it deals with U and V again. So we want to write an algebraic expression containing U and V without any trig functions. So give the restrictions on U and V. So we are going to do the exact same thing we did right here. But no numbers are given, just U and V are given. So let's do it again. And with that being said, make our appropriate substitutions. Inverse sine will be alpha. Inverse cosine will be beta. So let's bring that information down here. We'll first start with alpha. I wrote that as that. Yeah, you get it. Alpha. So we start with alpha equals the inverse sine of U. Just like the other ones, compose both sides with the sine function, and we get sine alpha equals U. But this can only happen on the inverse sines restrictions of negative pi over 2 to pi over 2. Okay. Which means now make your unit circle. There's negative pi over 2. There's pi over 2. And we will assume that this U is positive, which means it places it in quadrant 1. So there's my alpha. Okay, so sine puts opposite over hypotenuse, which means we need to change U into a fraction. So we make U into U over 1, which means the height will be U, the hypotenuse will be 1, and by Pythagorean theorem, you would have U squared plus B squared equal to 1 squared, which means you would get B squared equals 1 minus U squared, which B would be the square root of 1 minus U squared. So this would be 1, the base would be the square root of 1 minus U squared. Okay, now alpha contains all this information now, which means we do the same for beta. So beta, you get beta equals the inverse cosine of V. And again, compose both sides with cosine, and you get cosine beta equals V. But this can only happen on the inverse cosines restrictions, of 0 to pi. Okay, so make your unit circle. There's 0, there's pi. We assume that v is positive. So again, this places my triangle in quadrant 1. So there's beta. Okay, and cosine puts adjacent over hypotenuse, which means we need to make v into a fraction. So we put v over 1. V over 1. Okay, so this means the adjacent side is v, the hypotenuse is 1, and if you use Pythagorean theorem, it's going to be just like alpha. The height is going to be the square root of 1 minus v squared. And now, here's all the information that beta contains. We are now ready to roll. Okay, we're now ready to roll. All right, so bring our substitution back, right? Let's bring our substitution back, which means that we had sine of alpha plus beta again. So this becomes, oops, I don't want it in blue. Sine of alpha plus beta. Again, expand it by the sum formula for sine, which means you get sine alpha times cosine beta plus cosine alpha times sine beta. Okay, now all we have to do is call on the appropriate triangle, which is above. So the sine of alpha, which is given right there, or by the triangle, is u. U over 1, or u. Cosine beta, which is given over here, cosine beta is v. Plus cosine of alpha, now we call in a blue triangle, cosine of alpha puts adjacent over hypotenuse. So that just gives me the square root of 1 minus u squared times the sine of beta, which puts opposite over hypotenuse, which gives me the square root of 1 minus v squared. Well, that's it. We can't do anything else. This is u times v plus the square root of 1 minus u squared times the square root of 1 minus v squared. That's it. There's your algebraic expression containing u and v with no trig functions remaining. All right. I mean, you could combine these two, but there's no need to. This could become the square root of 1 minus u squared times 1 minus v squared. But again, you don't have to. All right, guys, that's it. I will finish B up, and I'll finish one more I left blank, which was over there. But that is it. Those are the sum and difference formula for cosine, sine, and tangent. Done.